All right, welcome everyone to GoLab 2020. I'm the talk manager, Latara. I'll be managing the talks and the Q&A sessions afterwards, and I just want to give everyone a gentle reminder that if you have questions to ask, I would like to direct you to the buttons underneath the chat headline. So next to the room chat, you'll see the question mark icon. Please keep your questions in that chat because we'll keep them organized and bring the speaker on afterwards to answer your questions live. So we're about to see the keynote called It Starts with a Solution, a Tale of Contributions by Roberto Clapis. I'm going to bring him live just to say hi and read his introduction. So hello, Roberto.
Hello there.
Thanks for coming. We're so happy to have you here.
Thank you for having me.
Yeah, definitely. So I'm going to just read a little bit about you, and then we'll get started with the video, okay? All right.
Okay.
So Roberto is a security engineer at Google, and this keynote is all about the proposals to go, and most of them are rejected or they take years to be accepted, and this can cause major frustration in people that want them to become a reality. So Roberto will tell a tale that starts with him on the user side and ends with him on the maintainer side, and he'll shed some light on this friction between the two. There is a lot of fear, uncertainty, and doubt around the contribution process to Go. With this keynote, he'll try to explain what lies behind it, what are the reasons for the apparent friction, and how to reason and think about it. Case studies, data, and examples will be shown along with personal experiences, and the main takeaways for this talk will be how to structure and think about a valid proposal, how to discuss one, and why this is complicated, and oftentimes a blocking process needs to be in place. So without further ado, we'll go ahead and watch the video. Enjoy, everyone, and stick around to the end so that we can do the live Q&A with the speaker. Thank you.
Hello everyone, and welcome to this opening keynote, A Tale of Contributions. Its subtitles, it starts with a solution, and you will find out later why. Before I get into the talk, I would like to say that I'm not making this talk as an official part of the Go team, which I'm not, or as a Googler, but merely as a passionate Go user. I want to contribute to this community and want to help you out with what I learned from trying to contribute to this community. That said, let's start with my tale. I have to start a little while back just to give you a little bit of understanding of where I come from. First, when I was using Go, I hated it. I really tried to like it because it was what I needed. I needed a performant language, a compiled language, something with a strong type system, but it was just awful to use for me because I was coming from Python and C#, and let's be honest, the error handling is baffling at first. The type system had the weird empty interface thing. I'm not a big fan of generics, but still, it didn't feel right sometimes. The lack of enums was just bothering. And many other things that bother me, like you cannot intersect two sets because sets don't exist, and you have to use maps keys and all of that stuff, including the types on the right. Like, my first impact was, why do they have to be on the right? Because I didn't know better, to be honest. For a while, I stopped using Go. It was just not good enough for me. And there was so much room for improvement, according to me back then. And I was kind of right. There is a lot of room for improvement. And in several projects, I had to use Go, and I wanted to use Go. I wanted to discover more about the language. So I tried to get past the initial annoyance, and I started liking it a bit, using it for personal projects, using it for work projects sometimes. But Again, every time I would find out something new about Go, there would be something that felt like it needed improvement. And I still think it does in many cases. And my experience has been just a constant drag in the beginning to try and make simple things hard because the language was fighting against me. Moreover, I tried to contribute. Like, I looked into how people were contributing, I looked at the issue tracker, I found issues that I wasn't aware of, and I thought, well, maybe we can fix them. But again, I didn't feel good enough. I mean, if you look at Go, it has been written by very experienced software engineers. It has gotten contributions from amazing people, some of which you will listen to in the rest of this conference. And I just didn't feel good enough. I just barely started getting my hands dirty with this language, and I felt like I couldn't provide any useful insights or feedback for the language to improve. So I decided to see how people were contributing to the language. So I started reading the issue tracker, and every now and then I would just open it, look at the new issues, look at what was solved, look at what was being opened, look at what people were complaining about. And after a while, actually a long while, of me using the language and just lurking in the issue tracker, I found a very simple issue in a very small package that I think basically no one uses, which is xmobile. People found out that os.executable was panicking on iOS. It was a small thing, because on iOS, the executable path variable is not initialized because the system doesn't allow you to do that. So the string would be empty. And as you can see from the code on the left side, that was just accessing the index 0 of a path that was assumed to be there, because it was, usually, before Go started supporting mobile. So I just proposed, well, why don't we just add a check, like these 3 lines that you see I added on the right, and that would have been a solution. But again, I didn't feel good enough to provide that type of feedback, so I just left that comment and moved on. I just left it there. Until 10 months later, I attended GopherCon UK, and there was this amazing contribution workshop led by Daniel Marty at the time, and it just showed me how simple and straightforward the process is. There are some some very rigid rules that you should follow just for sanity and for coherence and for good software development practices, but after all, it's made to lower the friction to contribute to the language. And since this bug was already agreed on, that it should have been fixed with my fix, I just proposed a CL. Now, I don't want your takeaway to be that you need to take part in the contribution workshop to understand how to contribute and to contribute. You just have to read the page that I linked here, because that's very explicative and tells you everything you need to know. I was just too lazy to do it myself. I much prefer the video format rather than a written format. That was nice. So after, I think, 3.5 years using Go and having already presented at conferences, I found the guts to submit a CL that fixed an issue, and I was happy. I was honestly happy. It felt like I was doing something good, and I moved on from being angry at the language and complaining at the language to providing something to make the language better, if not more for me, at least for someone else, like users of the mobile package. My takeaway for this first part was there are so many issues open in the Go issue tracker that you don't really have to be afraid that you will not be good enough to fix them, because they range from the simplest thing, like the one that I fixed, from the most complicated and really mind-boggling issues. And for those, yeah, maybe you need a little bit more time, but usually it's the Go team that takes care of these crazy stuff, like implementing preemption into the runtime. Now, I got at that point, and I thought, I want to contribute more. I want to do more. Maybe, I thought, the time to fix the stuff that really annoyed me had come. Because after a long while using the language, I had to do something to fix what initially created so much friction that I abandoned it at first. But there were problems because my issues were not new, and everything that already existed on the issue tracker that was describing more or less what I wanted, for example, enums, was there, already being discussed, not accepted, and other things were just outright rejected, like a proposal to have a try statement, or something that makes you not have to if or not nil every 3 lines if you're writing I/O code. And that was there and was closed. And sometimes they were reopened, some more data, some more evidence was added, and they were reclosed. Even documentation requests for stuff that I've been bitten by were bounced. And I was amazed. It's like, this looks like such an open language. It is open source, and it is open source first. So it's developed in the open source. Everything that is about the language follows the very clear guideline of contributing, being together. The code of conduct seemed very open. It is an open community, and yet it felt like it was so hard to add something and so hard to contribute even the smallest things, like a documentation line. So, as a scientist, I decided to start investigating on the why and collecting data and trying to find maybe a method and a certain approach that would allow me to understand better how to contribute and how the language wanted to get contributions. Because keep in mind, some contributions get accepted, some fixes get added, get merged, and some proposals are welcome. So I felt like I was missing something, and turns out I was. From outside, anything big was rejected and was just postponed to the go-to promise kind of thingy that we haven't seen. I mean, I've been hearing about GoTo since I joined the community, since I started using Go, but still that's nowhere to be found because understandably the Go team wants to do it properly. We don't want something like Python 3 and destroy the ecosystem. But again, my main takeaway so far had been just frustration. I could not find a good reason to keep just rejecting and turning off proposals and fixes. So I decided to go a bit deeper, and here is some data. Sometimes people propose a change list to fix maybe something that is an obvious bug. And I actually have done that in the past, and I got rejected because there wasn't a bug open. Maybe the bug is obvious, like there is an off by 1 in an array in a string concatenation function. Yeah, but you should still discuss it, because maybe there's a reason it was there, maybe you didn't read the documentation properly, so this is an intended behavior. And a change list on Gerrit or GitHub, in that case a PR, is not the right place to discuss these things. First, because it kind of gets lost, and second, because it's less clear, less people get notifications, and there are no processes involved to like link your CL and give a history to that. So if anything, just even if you find the simplest bug and a clear bug, just open an issue. Do not send a CL. And even if you open an issue, until you get some kind of an understanding by the team, or like the maintainers for their package agree that this is a bug that should fix, don't start writing the CL. Even for proposals and bug fixes that get accepted, they usually change in scope a lot, like broadly, even changes proposed by the Go team. So don't waste your time, don't waste your work. I know that you might be eager to get something fixed, but it's sometimes better to just be sure that you're doing the right thing. If you're proposing a doc change, you should know that I've been turned down in one of my bugs because there are some subtle assumptions in the Go documentation, which are stuff that we never document, and you should not just know about it. And I linked to the comment that Brad Fitz wrote in response to my bug, and that just made me realize that he was right. Some of those assumptions were already in my mind. I just didn't ever make them explicit. So in general, we only document the abnormal cases. So if you're proposing a doc change that says this struct is not safe for concurrent use, or like zero value for this type is not usable, or stuff like that, you should know that that is probably going to be rejected because that is implied by anything. If a struct is safe for concurrent use, that's usually documented. Might not be, but for sure a stronger requirement like a zero value being usable is not to be assumed. Again, there is one more problem with documentation. I think that one of the best features of Go is its documentation, and every time I browse GoDoc or the new site, I always try, I always find what I need, and I usually don't have to read too much. Like every type has a small and concise explanation. Sometimes there are examples, and an example sometimes explains much more than just, I don't know, a paragraph explaining stuff. And I love it. I love the experience of interacting with the GoDoc. Since I started using Go, I basically never opened Stack Overflow again, which says a lot about the doc that we have. But keeping a doc like that is hard. I don't know if any one of you have ever heard of documentation creep, which is the process for which documentation just grows and creeps everywhere, and it starts being unusable because now that you have let it grow wildly and freely, everyone that needs to use your type will probably miss the important bits thereafter because, let's be honest, first, we are programmers, we are lazy. Second, we are programmers, we don't have time. So if you write a page of documentation for every type, no one is going to read it, let's be honest. So we have to carefully pick what we put in the documentation. And again, sometimes if a piece of documentation is unclear, and that might cause vulnerability in users' code, of course we're going to add that documentation, or like if we realize that some behavior is oddly unexpected, that's going to be documented. So I don't want to put you off, but like if you have to add a piece of documentation to help others not make the same mistake you did, think maybe if the mistake you made by reading the doc, maybe quickly or not reading the doc at all because you just were using the type, like most of the time we do, is just unlikely. Because maybe you come from Haskell and you expected a certain function to behave in a certain way, but most people don't come from a Haskell, and some assumptions are just better left unstated if 99% of the people are going to get them right. Now, bug fixes are another story. A bug is a bug, let's be honest. There are some functions in Go that don't behave as expected, and that's just a thing because Go was implemented by humans and the standard library was implemented by humans. So some code that is in there doesn't behave as one would expect. Problem is that Go has a strong guarantee, and Go guarantees that if you're using Go 1, your code should keep working. And unless the broken behavior is a vulnerability, it's very unlikely to get changed. And I've seen bugs being reported to the thumped package that is basically used by every executable out there. And those are bugs. Those are real issues. Those are quirks and odd behaviors, but we can't change them. Those are meant to stay until we switch to Go 2. Those things are going to stay there because we don't want a program or the test of a certain program that is relied upon to break just because there is a subtle bug. I'm not talking about crashes here, but just weird behaviors. Those are most likely to become documentations, to become additional documentation pieces. You should also keep in mind that sometimes there is a bug that you want fixed, or you're proposing an addition to a vet check or stuff like that, and that might work perfectly for the standard library, but maybe someone uses another library to do what you're trying to do. It might break. Like, I've seen many proposals being put out, one of which is linked in this slide, to change vet checks for struct tags. Struct tags are those things where you put a backtick next to field of a struct, and that allows you to, for example, instruct the JSON package to use a certain name instead of the one of the field, and omit it if it is empty, and stuff like that. Those checks, those vet checks, would be easy to write if people only used the standard library JSON package. But we don't know how many packages out there encode and decode JSON. I mean, we might know, but just for the open source bits, and this is a free form text. Struct tags are not defined by the language. They are just a string in the spec. So we cannot write a language level check for something that is implementation specific. And so those are usually also rejected. Moreover, sometimes fixing a bug is just not worth it. Some bugs are very small, affect very little, very few users, and they've been there for a very long time, and maybe after 12 years that a function has been used, someone reports, hey, if you do these specific things, this function misbehaves. And that specific things only has happened after more than a decade, and fixing it would require to change the entire package and break every dependence on that package. In which case, the documentation will just say, do not do this. One example is the ticker stop in the time package, so a pretty used package, I would say. That function says, do not use the return value of this function because there is no correct use for it. And it's just there. It's just saying, this is broken. We know about it. We don't want to break users. Let's just keep it. We could change the signature to not return that value, but you know, the time package is used by way too many things to be broken just because of that. Now we get to the complicated part, which is proposals. Most of the stuff that I described in my first slide of this talk would have been proposals, like add enums to the language, or add a try function, or a set type. And those are the hardest one. Basically, no proposal gets accepted as is when it is first proposed. All of them are talked about, are discussed, are maybe even considered. Some prototypes are built, and sometimes they're just abandoned. Sometimes a little bit of them makes it into the language. Like at one point we saw that you can now add to sources numerical constants with underscores in them to make numerical constants easier to read. That's not a big change, but it started as a much bigger proposal, and it had so many proposed syntaxes, and at one point it just got that way, and I'm happy it did. But again, most proposals are either rejected or not accepted, and I'll tell you later why this is a big and important feature of our language. So rejecting proposals is an important part. And sometimes proposals are accepted or like left open and agreed on, but there is too many things to do, or we cannot implement them because of the Go 1 guarantee. But there is always another option, which is starting external first. So one example is fuzzing, for example. Fuzzing was just created an external tool, and it requires a different tool chain, is not built in Go yet, and it got quite successful. Many bugs were found thanks to it, and people in the Go team started picking up the fact that maybe it's useful, and a lot of Gophers were not using it because it was not first class. So creating an external package at first, or an external library that provides this feature, for example, even checker, like the error check tool that checks if you accidentally ignored an error that was returned by a function. That is an external package, and there are some proposals to add vet checks to support some of these things. So yeah, I think that when the team says, can we please first see these as an external package, do not take it as a rejection, just take it as a form of experimentation of your idea. Maybe it will turn out that you yourself will not like the idea anymore once you try to implement it. That said, there are some important things, some takeaways after, I don't know, 4 years that I've been doing this, that I want to share with you. First one is, please try to keep in mind the difference between a bug and a proposal. A bug is something that is there and doesn't behave as it should, as it's documented, as it's expected. A proposal is something that either is not there or is there, and you would like it to behave differently, or you would like to do an additional thing. And the first one is important that we fix, because usually it's damaging for most users. The second one is not so clear-cut. The reason for that is that proposals always have a much bigger hidden cost than just bug fixes. Keep in mind that when you change an API, users that have been using it for the longest time might be put off by your change. And this could be something like you fixed a behavior, but that behavior was relied upon in tests, for example, because people understood that a function was returning a certain thing, and they assert that that thing should be returned. And maybe the thing for their code is completely irrelevant. And another example could be that if you change an API that used to do a thing that people relied on, those people might just decide, why am I even keeping up with this? It's like, if we change these too much, people will not have the same experience that they have today with Go. What I love about Go is that sometimes I take code that I've written 5 years ago and I can still compile and run it on a modern machine, on a modern version of Go. And that's beautiful. And we don't want to make user go through the pain of learning something new every time they upgrade Go, because at that point they might as well use a different language, a maybe more stable one. And moreover, every change that we make to Go is very likely to stay there forever. Again, for the Go 1 guarantee. If you add a new API to a package, like the sort slice method, that is there to stay. And it's very likely that if we get generics in Go, that function signature is not going to change, because maybe there are some tests that take that function as an argument, and user code that takes that function, and we can't change the signature anymore, and that takes an empty interface, and at runtime uses reflection to check if it is a slice. Now, is this nice? No. Was this function needed? Probably, but maybe if we waited a tad bit more, we could have gotten it with a proper type system and proper compile time checks. So having a change like this, which is very easy to understand was a good idea, might not be the best in the whole scheme of things. And keep in mind that everything that we add, we have to maintain, and maybe it's going to be easy for you to just spend an afternoon writing the first implementation, and then it's up for the package maintainer to maintain it. So if it is just a small change, like a simple helper, it's probably fine. But if you write 20,000 lines of code to just add one feature to the HTTP package, that is likely to be a no, because, I mean, that's already complex enough, and too many moving parts are bad for stability. The last thing is Brenns Law. With a sufficient number of users of an API, it does not matter what you promise in the contract. All observable behaviors of your system will be depended on by somebody. So even if we don't document something, even if a behavior of a certain function is a bug, like is a non-intended behavior, there will be some code out there that relies on it. And there is even an SKCD about it, and I can maybe link it later. But this is the truest thing about software engineering that you have to keep in mind when you make a proposal. Now, let's say that you have listened to all of my banter and blabbering, and you decide that, yes, but my proposal is still worth it. Well, good, because we love good proposals. I like to read them, even if I'm not in the team, and just see, hey, this could actually improve the language. So I just hit the thumb up button, because that's democracy. Yay. So if you're planning to open a proposal, make sure that there is not one open yet. And if there is one and has been closed, consider if you have more data to add. So read the conversation and see, hey, yeah, this decision was taken 6 years ago, but we didn't have that other thing. Or like Linux or Windows did not implement this syscall. So maybe now it's time to open it again. And yeah, this is basically it. Only reopen or file a proposal if you have the data for it. Like, you should collect data on how many users are affected by the lack of something or the misbehavior of something, and you should have at least a ballpark idea of how much their experience would improve. And hence, again, the idea of external packages first, because that's a very clear data point. If you are saying, hey, this package already exists, like, I don't know, GorillaMax already exists, and everyone uses it because the standard library does not implement path parameters. And, well, yeah, that is true. So that is an important bit that you have to keep in mind. Data, and try to build a new case if there is already a proposal that was rejected. That said, do not forget this bit. Always explain why your proposal would make the language worse. It's very clear that if you're writing a proposal, you think the language can be made better. For sure it will, at least for you and all the other users that, like you, had a bad experience with something. But you should keep in mind that we are trying to build a community around the language, and a language that everyone relies on. Millions of Gophers every day, hopefully workday, write code, and they want their code to keep working. So there are some things that will necessarily make stuff worse, even additions, because Go has, like, I don't know, less than 20 keywords. It's a very simple language, so even adding something like an enum could be bothering to someone, because it's one more thing to learn when you start with the language. You should probably keep that in mind. So if you don't know how your beautiful proposal could make the language worse, follow this small list. I usually do the same, and sometimes I don't even open my proposals because I realize those negative bits are too big. So if there is an increase in complexity, the maintenance cost would be too big, you lose orthogonality, and this was a big problem, for example, with generics, because we had interfaces that somehow allow you to implement polymorphism and a bit of generic behavior, and when generics were proposed with contracts and everything, there was a big overlap with interfaces with some subtle semantical differences, but more or less some code could be written in two different ways. And that creates fissure in the ecosystem, and you don't want that, because One nice thing about Go libraries is that usually the way they're written is consistent with every other library, so they're very compatible and very much interchangeable. We don't want some interfaces to start requiring a generic signature and some other to require an interface signature and not being able to use those. Moreover, there are semantical issues like you're proposing to add a very high-level function to a package like I/O, or you're breaking backward compatibility for maybe a big improvement, but again, backward compatibility is important, and there are security implications with your proposal, and I'll detail more about these later. Or this would be a big improvement, not too bad, but only for a few users. And like, as some people in the Go team once said, Go does 100% of what you need 80% of the time. And I think we try to keep it that way. Now, if you're feeling frustrated and you're wondering, why should I do all of this? My answer is because everyone does, including the Go team. If you look at the proposals, I would say that most of them are from the Go team, and they have more or less the same rejection rate. And even when they are proposed in a very careful and detailed way, they get changed so much, like almost all of them get changed so much from the initial proposal that they end up being a completely different thing. That still solves the problem at hand, but it does it in a way that the initial author did not think about. If you want a simile or something that allows you to think about it, this is the way I put it. For me, Go is like Italian cooking. When I cook, I use very few ingredients, very high quality ingredients, and I put together in a way that I'm trying to improve and improve every day until I get to something that really tastes and looks good. All the things that you see here, I have cooked starting from 7 starting primary ingredients. And those are completely different foods. And this is what I think Go should look like. Very few high quality primitives that allow you to make the best things in the world that, well, Italy is famous for, but I might be bringing this a little bit too far. So I'm going to show you 3 examples of proposals and things that will maybe put a little bit of backing data on what I said for the past 30 minutes. This is a proposal of mine. I wanted to add an execute context method to the package I'm the maintainer of. So I maintain an HTML template, and I wanted to add an execute context method with a context parameter that would have been passed automatically or explicitly to the functions that wanted a context in their signature. And this was like, for example, to interrupt a template that was running for too long, or maybe a template that was rendering for a response that wasn't needed anymore because the request had their context cancelled. And I also needed it to pass nonces for CSP. This is a very technical thing about how securing against XSS, but basically I needed to pass additional values, and I didn't want the users of my libraries, which I was building on top of HTML template, to pass additional value on every call to execute. I just wanted to add these values to the context and retrieve them in the framework I was writing. Well, it turns out that passing the values was already possible with a bit of quirks around the clone func execute call chain. So the API that was already there was already enough. There was no good reason to add the extra function just for data. And the context cancellation bit got confused, complicated. Also, context in that case would have had the cancellation bit, but not the value bit. So at that point, I was closed and rejected for good reasons that I didn't see initially, and that was basically API bloat because we already have execute template and execute. That means that we would have had execute context template, execute, and execute template. And that would have been 4 functions to be roughly the same thing. And that was, in hindsight, not a good idea, but it was worth discussing it anyways. This instead is half successful example of proposal that I got recently. People asked to export the strip tags function in the HTML template package. Now, it is a useful function to strip tags from input because, for example, you want to show that the content, the textual content of a page in an RSS viewer. And that is great and everything. Problem is that strip tags is not secure. Just stripping tags from an input does not make it safe to embed in a web page. And HTML template is a security-centric package. So we changed this proposal, we discussed, and after a while we got to a conclusion that the best way to address this is to change the XNet HTML package to add examples or an exporter function to strip tags, with a disclaimer saying this is not secure per se, but maybe you're displaying text in a console, so we don't care about XSS. So again, the result is very different from the initial proposal, but the person that was asking for it was quite happy with the result because then they can just use that function from that other package. This one is a very interesting one. It's still open, still not done, and it might never get done, but this started as an external package. Then there was a proposal by another person that did not write the external package to make this first class, and then the Go team picked up some interest, and now there is a public proposal about it, and there are going to be some experimentations on it. I mean, there was an announcement on the official Go proposal site not long ago. So these got changed so many times, and still to today, the API is subject to change. So this is the importance of having a lot of data and a lot of users interested in it. And the reason this is successful is that many people were not fuzzing because it was not there, not because they couldn't or wouldn't. That said, a summary. Finding out what will make Go better is easy. Like, this is an easy task. I'll tell you what will make it better for me. Add enums. Done. Go is now better. Finding what will make it better for everyone without making it worse for anyone is hard. And this is why we need your help. And by we, I mean the community. We need your help to bring data, bring your experience, and bring the stuff that you love and hate about Go and everything that can help everyone else making an informed decision on what we should add and change. That said, thank you for listening to me. And if you want to contribute to Go, those are a couple of useful links. If you have any questions, you can find me on Twitter. That is my handle. And thanks. Enjoy this beautiful conference.
All right, that was fantastic. And now I am extremely hungry. So we are ready to go live now with Roberto to answer any and all questions you may have. So let's bring him on.
Hello there.
Hello, hi. So first of all, thanks so much for your contribution to GoLab. I'm very hungry, but besides that, do you have anything you'd like to add about your participation in the event?
Yeah, actually, I noticed by rewatching the talk that I forgot to say something very important, which is I think that some of the most valuable contributions that I've seen to Go are comments on issues, like people bringing data to the discussion, because that is what helps everyone making appropriate decisions on what to change. And I am the maintainer of a package, and sometimes I don't know how to make a decision on what to do when a bug arises or when a proposal is put forward. And having people bringing data and other use cases to the discussion is the most valuable thing, I would say.
Sounds good. Thanks for adding that. I see the chat very active with lots of food-related things, but I'm not seeing any questions. So if you guys have anything to add, definitely type it up in the Q&A. If not, we're just going to talk about food the whole time, which is fine for me, but it might make other people a little hungry. Yeah, I've noticed the acoustic mats on the wall too.
Oh, right. Otherwise, this room is too small and it would sound like I was giving a talk from the restroom.
Sure, sure.
Not nice.
All right. Well, I'll give people maybe a minute more to type anything they want to say to Roberto. Lots of thank yous. Lots of thank yous. Yeah, it was a fantastic keynote. Kept me interested, and I know nothing about Go, so thanks for that.
I'm
Um,
glad you liked it.
yeah. It's okay. I guess nobody's really having questions, so if that's it, well, I just want to say thanks so much for coming. Unfortunately, it is virtual this year, but hopefully next year will be a little better. We'll see. But
Yeah.
go ahead.
Yeah, in any case, it's nice that we could keep this running even in COVID times, because, I mean, it would be sad to just shut everything down and just wait for the next year.
Yeah.
I enjoy that you were able to pivot to an online conference.
Yeah,
Oh,
for sure. Yay, a question.
there is a question.
Yeah. So,
What was your
oh, go ahead. You wanted to read it? Sure.
Yeah, sorry. What was your background before Go, and how much time did it take you to get to the level to contribute? So my background was 4 years of Visual Basic.NET, 5 or so years of C#, Java, and Python mixed together, depending on the project, and a little bit of C. When I started with Go, I would, as I said at the beginning, just hate it and did not try to contribute, did not feel at the level to contributing. I think that my first contribution was 3 years later. I think it took me 3 years of using Go wrong to find out a proper way to contribute. Like, a thing that I did in the beginning was spawning Go routines everywhere, and my code would just hang or be too heavy or stuff like that. So I think Go is easy to pick up, but it takes a while to understand how to use it properly and nicely enough to contribute to the standard library or to the project. Unless by contribution you mean commenting to a bug, in which case any level is fine.
Excellent. Thank you for that. Let's see, just a few comments about the contribution. So Frederick says, I think one of the most important things we can learn from this talk is the knowledge you can grab from the issue tracker and discussions.
Right, and the sources. Because sometimes you read the issue tracker and people link to the sources, and you just follow the link and read the code, and sometimes you find comments that were left there, like to-dos in the standard library. I'm not kidding. There are several to-dos or like comments like, we should probably fix this. And it's just there. So yeah, source code and the issue tracker are extremely helpful to find out what to do or to contribute.
Awesome. All right. Well, I don't see anything else really. Do you guys have anything left to say? And I'll also ask Roberto if there's anything else maybe about your contribution or your background that you wanted to add before we wrap it up.
Oh, I would say that what really got me to contribute to the package that I'm maintaining right now was just that I really wanted something fixed or something changed, or like a more reactive workflow to some of the things that I was interacting with. And I felt like I could do it. And I just started reading the sources. And once I was confident enough with the package, I just asked if I could contribute more. I would say that this doesn't have to be a target or a purpose for anyone. Like, you don't have to get to the contribution level where you maintain a package or like you are extremely active on the issue tracker. Just do your bit. Do what you think is worth and appropriate for what you like.
Sounds good. Thank you for that. I'm sure that inspired some people who might have been a little hesitant to do that. So thank you. All right. Well, I guess that's it. So before we go, I just want to say thank you again, Roberto, for being here. We're happy to have you.
Yeah, thank you for inviting me.
Yeah. And hopefully next edition of GoLab, if it's live or virtual, who knows, but we hope to see you there in any case.
Yeah, for sure. I would be happy to.
Great, great. Well,
Bye.
have a great rest of your day and enjoy the conference.
Yep, for sure.
Thanks. All right, everyone. Well, that was it. I just have a few announcements before we go and welcome our next speaker in the other session. So first announcement is I just want to remind everyone that if you liked this, you can rate it on the agenda page of the GoLab site. And also a reminder that for the Ask Me Anything session of the Go team on Thursday, we have a Q&A kind of suggestion. So you can actually have some questions and you can also vote on the questions that are there. I put the link in the chat in case you were curious. You can also find that in the session on the agenda on Thursday. So in case you lose that link later on, it's in the session on the agenda. So without further ado, we'll be waiting for you at 10 past the hour, so 12:10, for the next talk of the day, which will be by Sina Siadat, called All About Interface Values, Common Patterns and Type Analysis for the Empty Interface in Go. So talk to you all soon. See you there. Bye-bye.